Okay, so we're back with the sum of squares, which is a squared plus b squared equals quantity a plus bi times quantity a minus bi, this binomial times that binomial. So again, I want to start with just checking this general case to make sure we are correct, and if we are, we're going to go on from there. So here's the binomials, a plus bi, here are the binomials, I should say, a minus bi, and we're going to multiply these guys and see what we get. There's a times a, and then there, here, and then here. Okay, so this gives me a squared minus abi. From the next one, bi times a, I can say plus abi. And then lastly, I get minus b squared I squared. Now remember, I didn't write it up here, but I should, that I squared is equal to -1. That's how we define the imaginary unit. I is equal to the square root of -1, so we can say I squared is equal to -1. That means that this guy right here is equal to -1. So this comes out to a squared. These two guys add up to 0, minus b squared times -1, which produces, indeed, a squared plus b squared. So that guy does check out. So that being said, let's take a look at some examples of sums of squares. And we'll start with a simple one. How about x squared plus 4? What's being squared to give you x squared? X. What's being squared to give you 4? 2. So I can say, if I wanted to write it down like that, I can say a is equal to x, comparing it to the general map up here. B is equal to 2. And this thing factors 2. You can use your a and your b here. X plus 2i, don't forget the I, times x minus 2i. And you need those i's in there so that eventually you get this squared thing that makes that become a positive. So there it is. Let's try another one. Example. It's pretty simple stuff. How about, I don't know, 4x squared plus 25y squared. Indeed, we have a sum of two things. We just need to check and verify whether or not these are squares. They are. Something squared gives us 4x squared, that is 2x. Something squared gives us 25y squared, that is 5y. So I can say our result is 2x plus 5yi times 2x minus 5yi. And that's it. Pretty simple stuff. Let me give you one more example. What if we had, well, here, I'll just make up another one. In fact, I'll use this, but what if we had 8x squared plus 50y squared? And you're saying, okay, it looks like a sum of squares, but 8 is nothing squared, nor is 50 anything squared. But I point this out just to remind you, always factor the greatest common factor first. Never forget about that. Look for a greatest common factor. And in fact, there is one. A factor of 2 can be found in these guys. So we're going to take out 2 first, and then we're looking at 4x squared plus 25y squared, which looks exactly like the previous example. And we know that this thing factors in those two guys, into those two guys. So our final result, don't forget your greatest common factor, is 2 times 2x plus 5yi times 2x minus 5yi. And that's it. Piece of cake. All right. Now we're going to move on to the next special form I wanted to talk about, which was the perfect square trinomial.